Hello everyone. Thank you so much for joining Levo's MCP server launch and live demo. I'm super excited to present this. Today's topic is pretty exciting and timely. We'll look at how Levo's MCP server opens up new possibilities in API security. At a very high level, this is the agenda. We will give a brief overview of Levo, especially for those of you who may not know about us. But we'll talk about the big problem that is introduced by AI and why MCP server and how it solves problem. And we'll look at some use cases. We'll do a demo showing how we are solving some of those use cases, and we'll open it up for question and answers. A bit about Levo. We started in 2021. Levo is a proactive API security platform, and we help enterprises to secure their applications. And we do that by increasing the security coverage to 100x at one-tenth the cost of legacy tools. And to do that, Levo has built a platform that helps enterprises to continuously discover, document, and security test all their applications and APIs at an unprecedented scale. And more specifically, we do it as early as possible in the software development lifecycle. That's pretty unique to us. And we are trusted by several regulated industries. We are pretty big in BFSI sector. We have several customers from financial sector, including some public companies. What's a big problem? We have a big problem today because of AI. I call it as the AI productivity paradox. The development has increased uh, pace, but is security following at the same pace? Faster development actually means more security debt. We all know, looking at AI tools that are increasing the developer speed by almost 300%, but is the security is scaled at the same pace? We are seeing security still done manually to large extent, and the gap between the development pace and security is often growing exponentially. And what if AI agents actually could make all these APIs vulnerability free, bug free? Wouldn't that be awesome? But I actually challenge that cannot happen without the right context for these AI tools. So AI tools are good at certain things, but without context, they cannot do it well, and we all know they hallucinate. Um, and what is that context that's missing, and why is it missing? Today, a lot of AI tools are disjointed from the infrastructure and cybersecurity tools knowledge that is built for your enterprise and for your applications. You look at like ChatGPT, Claude, or Cursor, the way they are used, we have to copy and paste certain context into it, but they lack that context. Sometimes they are able to build context about the code, but not about the infrastructure and the cybersecurity tools status. A lot of knowledge base that's built for your enterprises, especially Levo builds a complete knowledge base of your infrastructure, applications, and APIs, but all of that is not available for the AI tools. That's the reason I say they cannot fully solve this problem of completely making APIs vulnerable. But welcome to Levo's MCP server. That's exactly the problem that we want to solve to make AI tools as superheroes or security superheroes, right? And we do that by exposing your cybersecurity information and knowledge in real time as context to all these tools. And thanks to MCP Model Context Protocol, a common industry standard protocol that is introduced. And Levo has built an MCP server on top of our rich knowledge base that we built for your APIs. And the entire context sharing has become seamless with this. With this, we will be able to empower your AI agents to actually find and fix vulnerabilities in the context of your application, your infrastructure, your APIs, the way you do authentication and all of it. And you can do all of it directly from ChatGPT, Cloud, or Cursor kind of tools that we use on daily basis. You can tap into the power of LLMs, which are pretty good at generating code, generating certain test plans, generating attack patterns, all of it. by providing the context and doing it for your applications and your APIs. And through this, we want to bring the AI productivity. We want to fix the AI productivity paradox and bring the AI productivity to the next level, especially in API security automation. At a very high level, this is how the architecture looks, which is what I just explained. There's an MCP, the model context protocol as a common layer, solves this problem highly. And we have an MCP server that sits on top of our API layer and exposing all the rich information, whether it is inventories, documentation, or authn and auth knowledge stuff that we build for your applications, or the sensitive data details and the vulnerabilities. All of that is exposed to all these AI tools that are like that you are using on daily basis. So this those tools and AI is not just generating or not just solving something, it is solving something for your applications now. And this is great because with this, like security people can use the AI tools that they are using with the in the context of their applications, and they can find more vulnerabilities. They can remediate the existing vulnerabilities much faster. They can reproduce them, or they can even triage them much faster. They can generate specialized reports. Engineering teams don't have to leave their IDEs because whether they have questions about APIs or whether they want to integrate two different APIs or whether they want to fix or remediate some of the vulnerabilities in the APIs, all of that they can do at the comfort of the IDE, like Cursor, Windsurf, or directly with Levo MCP server. And finally, the reporting, whether it is compliance teams or other teams who needs reporting, you're not limited by some predefined set of reports. You can actually query this dynamically and craft reports that are very, very specific to your need because the MCP server gives you that power to dynamically filter and create reports, and you can tap into existing all the GPTs or LLMs, or if you have any specialized tool that's able to create nice reports, you can tap into all those as well. So hopefully you can see the power here. We are basically marrying two different walls that are equally powerful. Levo's knowledge graph with full context of your application, say apps and infra, and the LLMs and AI tools, which are pretty powerful tools or other things. And we have launched this couple of weeks ago already. We have given it to few companies. We have been working with them on few use cases. Some large fintechs are already using this, and they have seen significant improvement in their productivity, and especially the power of dynamically querying this information. And we are working with more customers to add more tools. Let's look at some use cases, some early use cases that we built using this in a demo. Handing it off to my colleague Ravi for the demo.
Thank you everyone for joining us today, and thank you Bichi for the brilliant introduction. My name is Ravi and I'll be your host during this demo session today. I've been working alongside with my team to build this in Levo's MCP server for quite some time now, and I'm very excited to walk you through it. I'll be walking you through the quick overview of how to configure or to initialize this MCP server, and why does it matter, how it can help you, and I'll keep things clear and crisp to the point. So I'll request all you to park your questions towards the end. So here we have cursor tool which I'll be using to illustrate all the use cases today. Uh, the how to configure Levo's MCP server, it's pretty simple. You just add in a JSON payload, the connection name, URL, and token to authorize with the MCP server. And these are the bunch of tools that out of the box we are supporting at the moment. We'll be expanding more on this, but most of the use cases that we are going to see today are be around this. So let's get started with the first prompt, right? The first use case is pretty simple, looking at querying simple application endpoints and see the how the security posture for a given endpoint, and try to generate some report, simple report, right? So here's a simple prompt. I already have an application called Crappy Web, which has bunch of endpoints. This it picked up the right tool here, and this is from the prompt. It observed, this particular tool requires a param called app name, and it tried injecting with that. I'm running it, and let's see how the LLM I'm using today, Claude LLM. See how it goes. Yeah, so now I can see, these are list of endpoints that I have. I can go through quick summary and see, there are 22 endpoints. It also categorized all these endpoints based on request parameter, request segments. uh, Based on those attributes, it listed all of them, under each category, like mechanic, workshop, and authentication, and user management, vehicle management. So let's pick one of the API, like vehicle management, and see what's the endpoint coverage for this, right? This is a simple query to asking, what's the test coverage for this endpoint. What this is doing is, like, again, setting all the payload information as an input, and going ahead and running this tool. This will give us a quick summary of what are the tests we ran so far on this endpoint. So on the Levo dashboard, I already ran before this demo bunch of tests on this. Authentication is succeeded, and baseline for this is succeeded, like likewise course and rate limiting failed for this endpoint, right? So similarly, we can try for a bunch of other endpoints as well. But this is how we can get a quick summary. We can see the overall coverage, and lots of other details, right? And moving ahead, a simple report generation prompt. I'm asking, give me CSV report format of all the PI information present in the list of endpoints containing the email address. Right now I'm saying, I'm interested in email address. I'm filtering only email address related endpoints. And I'm also asking in a particular format called, give me list of these columns: method, path, PI field, and confidence level. Here is a extract that I received from the response, and LLM tailored for me this particular CSV, and just copy and paste into a file, and just I can use this file to plot any widgets, dashboards, or any build any use cases from this, right? And this current use case is pretty simple, but this can grow to a very complex use case where you can bring in all sort of information and chart complex use cases, and yeah, complex widgets. Yeah, this pretty much summarizes the use case of security posture and reports, and then we'll get to the other use cases. In this use case, we'll be looking at to get an endpoint related information, and generate a curl command for that, and try to exploit that command. So basically, this use case is all about testing an endpoint for vulnerabilities. That's using Levo's information captured using the sensor, that we call it trace, that will try to get the information, and generate some curl command, exploitable commands, and see how it goes from there. So this is a prompt to get the traces. I'm using an endpoint called mechanic report, where I know there are bunch of uh, vulnerabilities present, right? So this is a trace information. In this, I'm particularly interested in basically the uh, headers. I captured the header information that I'm interested in, the bearer token, and I'm using that to generate a curl command. I'm asking it to give me a curl command using the bearer token, and this is the target URL, right? This is my target URL, and I can just run this curl command, and it should give me some response. But let me leverage this script to this script file to generate bunch of curl commands instead. So I have this file called exploit script.sh, and I'm using this simple shell script where I'll go ahead and run this, but I'll walk you through what the prompt is about, right? So here I'm asking, I want to test for broken user authentication, BOLA, BFLA, and also leaving to LLM, if you want to try any more different categories, please go ahead and generate me the script file for this. So and also populate with the comments, so I can just skim through the script file and understand for myself what's happening with the script and how is it exploiting, right? So there are already bunch of commands that usually run from the level perspective, when do we do security testing on a particular set of endpoints or an application. So more or less this would also do the same here, just that we're trying to get what side of vulnerabilities this endpoint is susceptible to, and based on that susceptibility, and we are just running these. So this is script I'm accepting, and let's go ahead and run this, right? So now we should see a detailed report, how this you know goes through, and what are the okay, it seems successful. It tried this script and it found, based on the request payloads and various exploitable things, it the evidences is clear that it tried these steps, and broken user authentication is success. That means there is a presence of this vulnerability. It is prone to, this particular endpoint is prone to BUA, and also BOLA and BFLA. These are all success, and additionally it also tried this XSS injection parameters, and rate limiting, and some other injection tests. So on a high level, yes, this is a use case to get information from Levo, that's from the observability side of the product, get the traces, and using that, there are already successful run tests. We can reuse them, or otherwise just ask LLM to generate any interested category related exploitable commands, run those against this application endpoint, and yeah, get a quick summary of how the script turns out, right? And yeah, next we'll see one more use case. In this use case we'll see you know auto generation of code using of the client SDK code based on the OpenAPI spec for an application endpoint. So what we'll do is, we'll write a prompt, simple prompt to fetch an OpenAPI spec from the Levo, that's been instrumented by Levo eBPF sensor, and the specs are generated and available in the dashboard. I am asking LLM to fetch me using MCP server, Levo's MCP server, get me application endpoint, validate coupons, OpenAPI spec, and I'm interested in headers, parameters, request body, response body, and security schemes. So all that information I need to make a successful call and get a successful response from the OpenAPI specification using that, right? Here is a call it made. This is a payload input it sent, and this is a response it received. It This is just rendering of the text of the OpenAPI spec JSON. This is the information, and this is the path, and this is a get method, and these are the parameters. It takes coupon code as a one request parameters, and there's a successful response if it returns. This is a scheme of it, and there's a security scheme present called bearer token, which is an HTTP bearer JWT format token. So now we know what it takes to make that this API call, right? So I have this client SDK here called couple of files here, main and API client. This main has a function to make a login call and validate coupon. So we like to implement implementation for this. So this file has already implementation for login. Now based on the specification, I want to write my own SDK for to make this call. So now I'll ask LLM to complete this code. It's a simple prompt, and based on the spec that's already served from the Levo, what it does is I need to tag here the my file here. Let me tag API client API client.py and main.py and rerun this prompt again. So I'm saying is, complete valid function for me based on the OpenAPI spec that's fetched earlier. So from this, it tries to generate the code, and let's go ahead and accept it and see what it's doing. So what it is doing is, this is, it's trying to handle some exception cases and try to handle the request parameter coupon and shooting an API call using the endpoint information. And we know that it needs an bearer token, HTTP authorization token. So it's sending that, and it's also adding an accept header and passing the params, and if the response is successful, it's sending back, otherwise it's raising an exception. This is a pretty straightforward and a simple approach to an SDK implementation using just the spec that's already generated by the Levo, right? And yeah, this is a simple use case, but in the the complexity can increase, and we can iterate over this and add more business logic to it if required, and and lot more can be possible. This use case we'll be looking into vulnerability remediation part. So let's pick an API where we know Levo has already discovered a bunch of vulnerabilities for the endpoint. So from the active security testing in the Levo, for endpoint mechanic report, which is part of the workshop module in the crappy, uh, it has discovered a couple of vulnerabilities. One of them being BUA, broken user authentication, and we'll try, which is a high severity vulnerability, and we'll try and see how to fix that. Have access to the code base. So I opened a couple of related files where the related code is present, and let's walk through the code and let's try to fix it. Right? Let me run this command first and help you understand what's happening here. So I'm adding a couple of files here to the context. I'm asking it to fix the vulnerability. So why did I add these two files and this folder? So the mechanic report is, this is the API, and this is the report view for that. Let me run that command and see what it does. So this is the report view, and the changes, before I accept them, let me walk you through the changes and show you the changes it is making, it's suggesting us to make. uh, yes, so this is a report view where it is missing JWT auth required, so that's actually causing the BUA. It analyzed the code and looked up all the folder and how the authentication is being done in other parts of the code base, and there is already annotation called JWT auth required. So using this annotation, it will enforce this particular method to enforce the authentication when when client is making a request. So that it understood from the code base, and it's suggesting us to make these changes. So let's go ahead and make these changes, right? So I made the changes, and so now before I run this fixed code, let me show you how what's the current behavior of this application looks like. I've already have this application been running and my setup in a Docker setup. So I'm using a Docker command to make a curl request to that workshop module and see how the what's the response looks like. So it's a basically simple call request using Docker command, and this is the Docker command. It gave us 200 response with this as a successful response. So it says 200. Okay, so this is the current behavior before applying these changes. Now that we applied the authorization enforcing check, ideally after applying this change and restarting the Docker containers, we should not be seeing 200 response. We should see something else other than 200. Okay, let's see if that happens, right? For that, let me rebuild the image. So I'm seeding into the workshop module where my code base is present and I'm building the image for that code workshop module, right? So this will take a while. While this generates, let us go through the code changes it made. So these are the code changes it made. So yeah, JWT auth token, this is a key change, and in addition to that, it's if user is not present, it's throwing us back, authentication required 401. This is the key information, key change here. I'm building the image now, and let's see. Along with this, it also made few some non-trivial changes, but we can ignore for now. But these are the key changes. So now once we build this image, we'll bring up the containers and see and try out the API, the API that we tried earlier, and it should not give the 200 response. It should give something other than 200 response that we will validate. So Levo is already, we for this is one just endpoint, and similar to this particular endpoint, there are bunch of other more endpoints to which we have run security tests. So now what I'm doing is just again seeding into that folder and doing docker compose up to bring up the container, restart the container, recreate the container for this workshop. uh, it's just stopping the copy web, and next it should recreate the workshop container with the new code base. Yes, that's doing it now. And yeah, so let's go ahead and see, try that same API that we tried, which got the 200 response, right? So now let me head, I'm hitting the API. Okay, what's the response? 401. It's not 201. I have not injected any token here. Just the same API workshop mechanic report that I used with the same parameter. It's giving me 401 because now we are enforcing JW auth required. Let's give it a try, passing a JW token. Let's see what happens, right? To get a JW token for our application, we need to hit an login API. So this is a call request to do that. It's again using crappy identity is one of the service in the crappy microservices, which is responsible for authorization and authentication. So we are trying to log in this API. So give me token to copy. Let me copy this. So let me copy this and add this token to the earlier request that we made for the crappy mechanic report. This as a bearer token, right? So adding this as a bearer token to the earlier request. So it is the same again, mechanic report one, same parameter, just added this authorization header with the bearer JWT token. Hope I copied the token properly. Let's see, run this curl request and see how it goes. Again, this is a curl request again on the crappy workshop container. This is taking a while. Gemini is a little slow probably. For earlier use cases, I've used Claude, but there is some issues with Claude, so I've switched to Gemini. So ideally, it should not throw 401 because we are sending the token, unless the token I copied is, has some issues with copy paste. Otherwise, we should not see any other issues. Okay, this is taking forever. Let me try again. Yeah. So what's the response? 200. Success with this, and we got the response back. Awesome. So this proves that with just evidence that's captured from the active security testing from Levo, with the evidences and exploitable commands and all the metadata information that it captured, how to evidences of the vulnerability, you can use that and apply generate remediation fixes for your code. This is a very simple use case, and the use cases can be more complex, and you can iterate over this and add some business logic wherever required, and yeah, uh, much more can be done. That wraps up my part of the demo. Thanks a lot for your time and attention, everyone. Now I'll hand it back over to you, Pichi. He'll give you a quick recap, and yeah, we'll get into a Q&A session. Over to you, Pichi. Thank you.
Okay, back from the demo. Hopefully, you've seen the power of what can be done here. And these are just initial use cases. We are actually doubling down, and we'd love to hear if you have any particular use cases. We're more than happy to solve them and work with you. But just to recap, what Levo's MCP server has enabled is taking us from this world where like the AI tools that we are using on daily basis were disjointed from your infrastructure and security, cybersecurity posture context to a world where they have the full context readily available, that too in real time, so that whatever they are generating, whatever they are solving is directly for your applications and your infrastructure. And say goodbye to hallucination. And this should definitely make the AI tools as security superheroes for your organization. And this is just the beginning. We, apart from adding more tools, this quarter we are adding more tools and more workflows to the MCP server. But we have much bigger plans. Like we plan to integrate the MCP with other co-pilots and also solve regulatory specific or framework specific workflows. And in addition to that, we are working with a couple of companies to get this MCP server into their own MCP registry. Some of the large enterprises are trying to have a vetted registry internally, and we'll also try to get this into other MCP registries wherever it makes sense. And after this, we are actually getting started on securing the MCP servers themselves because we all know MCP is the new API layer, and Levo would be playing a big role in securing the new API layer. Hope you all found this helpful. We are doing Q&A. We'll be hanging around to actually answer your questions live. Whether you are watching this in LinkedIn or YouTube, please drop a note, ask questions, drop some ideas, or give us few use cases or even challenges, and we are more than happy to take them and work with. Thank you very much for your time.